Hi everyone, my name is Kayhan and I'm a master's student at the American University. I'm presenting this tutorial for helping students to get familiar with the software named Engineering Equation Solver or EES. EES is a commercial software which helps the student to solve heat transfer and thermodynamics problems easier with more accuracy. And the basic properties of elements and materials have been stored in this software, and these store data not only will eliminate the time of searching in thermodynamics table but also will reduce the human error in calculation process. And in the environment of these we can go to function info, and if we click on the thermodynamic properties, we can select, for example, oxygen, and here, and we can search for the density if we have the temperature and the pressure. And first of all, at the bottom of the equation window, or in here, or in the option, we can select unit system, and we can set SI unit system or English unit system. And if we set SI unit system, we have Celsius for temperature, joule and kilojoule, kilogram for mass, and we have Pascal, bar, kilopascal and megapascal for the pressure unit. And in the English system, we have pound mole and psi or atmosphere, and for the pressure, and for temperature we have Fahrenheit and Rankine. And we put in the system of SI again, and also in the preferences we have the display, and we can also have fonts and the size of the fonts here. In addition, obviously EES would solve the basic arithmetic operations such as addition, subtraction, division, multiplication, and exponentiation. And for example, in here, if we in 5-order equation, we can add, subtract, multiplicate, divide, and exponentiate with the variable that we have. If we have the a equal to 5, b equal to 7, c equal to 9, we can use these symbols to operate for the mentioned operation. We can use plus for addition, we can use hyphen for subtraction, asterisk for multiplication, slash for division, and the caret for exponentiation. And if we click on the solve, we will achieve to our desirable results, as you can see in the solution. The symbols of these orders are commonly used in several mathematical softwares such as MATLAB, and so that's how EES would help us to operate some simple mathematical operation. In another case, EES can solve a system of linear equation. As you can see in this folder, we have 4 nonlinear equations with 4 parameters. 2a plus 4b minus 6c plus 2d equal minus 20, 7a minus 2c plus 3d equal minus 17, minus 7a plus 2b minus 2c minus 5d equal 25, 3a plus 4b minus 5c plus d equal 19. If we check equations, we have no syntax error in here, and we can go for solving. If we solve and continue, we will achieve to our 4 parameters that the EES has been solve these four equations simultaneously, and the desirable answer would be provided by the help of EES. With the help of the EES, we can solve the thermodynamics problems. For example, in here I brought some essential problems, and from the chapter 8, the question 176. Air at 1 atmosphere and 40 degrees Celsius flows in a 8 centimeter diameter pipe at a rate of 2,500 liter per minute. The friction factor is determined from the Moody chart to be 0.027. The required power input to overcome the pressure drop for a pipe length of 150 meter is, the question is what? And we are going to create the data and write the data from the question. First of all, the question said that the pressure is 1 atmosphere, so P equal to 101 325 Pascal, which is equal to 1 atmosphere, and in the SI units, and the temperature is 40, and we put the exact temperature 40 degrees Celsius. And another factor is 8. We need to write D is equal to 0.08 meter, and in the SI units we have meter degrees Celsius and Pascal. V dot is equal 2,500 liter per minute, but this unit is not sufficient unit, and we need to convert liter to meter to cubic meter, so we use asterisks for converting liter per minute to cubic meter per second, which is the common unit for V dot in SI units. The friction factor is 0.027, and the length is 150 meter, and the rho, which is the rho of air, is equal to density and density of air in the temperature that mentioned above, and the pressure that mentioned above. And we also can create this density, and we can achieve the rho of air by using the option and the function input that mentioned earlier. And if we go to thermodynamics properties, ideal gas, we can find air, and we can find density in here, which have the temperature and pressure, Pascal and degrees Celsius. So if we paste the exact equation will be provided, but the rho is not correct in here. Yeah, rho is equal density. Yeah, this is the exact thing that we typed before. And another thing is the area that pipe, which is P multiplied by diameter on the power of 2 divided by 4, and V is equal to the volume is equal to V dot divided by the area, and delta P is actually friction factor multiplied by length divided by diameter, and rho, and V power of 2 divided by 2. V dot, W dot, which is equal to V dot and multiplied by delta P. So if we check these equations, we can go to check equations, and it says that no syntax error has been detected. So if we put the solve, we will achieve the what's the question wanted, which is W dot is equal to 81.7, which is the answer of D. And if we go through window or press F10, our formulation would be like the mathematical that we write in the papers, and we have the conversion in here, and the ACV, delta P, and W dot. So this is how EES would help us to solve thermodynamic problems. EES also have parametric tables, which allow students to solve a problem in a wide range of variable parameters in a specific domain. For example, in the exact program or example, if we want to set temperature as a variable, we can go to the tables and define new parameters table as T in here, and we need to define actually answer to create the table that gives us the exact answer. So if we have two variables in table, T and double dot, so we create this table, and if we click on the table variable, we can set the first value such as 40 in the exact example, and we can set the last variable such as 60, and we will create this. We can actually set an increment such as 2, 3, anything, and we can create the exact table. We can increase the number of the row such as 15, and increase our calculation domain. And when we set these variables, we can go to check the equations and the table, and then we can press the solve table, and the answer will be provided by the EES. And as you can see, we have the amount of 81.7 for the temperature of 40, the exact amount that we calculated in the previous. So that's how EES can help us to solve an example in a wider range for a parameter, instead of solving it over and over.